Hello everyone, how are you guys doing? I hope you're all doing amazing. So I'm Single here and today we'll be working on some Kaggle problems. So so let's directly get straight into it. So if you know about Lux AI, they make problems where you have to somehow they present a game environment basically, and you have to train an AI that will be going through competition with various other teams, and they will even show you live matches and stuff, which is kind of cool. It's kind of exciting. So I wanted to take up this problem. It has been released only 5 days ago, and I've not looked into the details yet. I've just seen the title or whatever, and it's just directly joined the competition. Oh, I guess I haven't even joined the competition yet. So cool. So we'll be joining the competition right now, and we'll get started with working on this problem. So a basic approach you have to take when working on a Kegel problem, in my experience till now, which is very timid essay, and I'm still getting my hang with Kaggle. I've worked on some data science problems, and that's the job I do. So yeah, but basically I still have a lot to learn in terms of how to work better with Kaggle combinations, how to look at the data set, how to use the public notebooks, and all of that stuff. So I think a general approach that should work best in both of the cases, and with approach that I'll be taking for today would be, first of all, we'll be getting through the problem itself, so problem description and the environment that they have presented. We'll be looking through that. GitHub to the game, whatever. And after that, after understanding all the evaluation metrics they will be using and the problem that are presenting to us, we'll be looking at some public notebooks to get a hang of it, of what people are trying. And then after having a first initial implementation, which would be a very simple model, and getting our first submission done, we should be able to get the whole ropes on how we really want to do this problem, and then we'll start focusing on actually implementing some creative ideas in it, right? And yeah, it's a live stream. I want you guys to give me good ideas as well, and we will be able to figure out some things, just you know if you have a great idea and you want to work on the problem with me, just request and we can form a team or something. I don't know how that exactly works, but we can figure it out. We will create a team. So yeah, I can just send you an invite if you DM me. So that's cool. You can comment and we will work on a team. So let's get started with the problem description. So welcome to season 3. The goal of this competition is to create and or train AI bots to play a novel multi-agent 1v1 game against other submitted agents. We hope to create a fun multi-agent competition for all in addition to advancing research into AI, imitation, reinforcement learning, and meta learning. Learn more about the competition specifics by reading below. Okay, multi-agent 1v1 game. Okay. With the help of 600 plus space organization, Mark has been terraformed successfully. Nice. Colonies have been established successfully by multiple space organizations thanks to the rapidly growing lichen fields on the planet. The introduction of an atmosphere has been enabled colonists to start thinking about the future beyond Mars. Mysteriously, new deep space telescopes launched from the Mars revealed some ancient architecture floating beyond the solar system, hidden in the midst of asteroids and nebula gas. Perhaps they were relics of some previous sentient species. Seeking to learn more about the secret of the universe, new expeditions of ships were set out deep into the space to explore these relics and study them. What will they discover? Which expedition will be remembered for the rest of the history for unlocking the secrets of the relics? The Lux AI challenge is a competition where competitors design agents to tackle a multivariable optimization, resource gathering, and allocation problem in a 1v1 space scenario against other competitors. In addition to optimization, successful agents must be capable of analyzing their opponent and developing appropriate policies to get the upper hand. Wow. Analyze their opponents. It's kind of tricky. Multivariable optimization, resource gathering, and allocation problem. Yeah, that's a lot of words. All code can be found at our GitHub. Make sure to give it a star while you are there. Make sure to join our community Discord to chat, strategize, and learn with other competitors. We'll be posting announcements on the Kaggle forums and on the Discord. Each day, your team is able to submit up to 5 bots. Each submission will play episodes against other bots on the ladder that will have a similar skill ranking. Over time, skill rating will go up with wins or downs with losses and evened out with ties. Each board submitter will continue to play the episodes until the end of the competition, with newer boards playing a much more frequent number of episodes. On the leaderboard, only your best scoring board will be shown, but you can track the progress of all your submissions on your submission page. Each submission has an estimated skill rating which is modeled on a Gaussian. Okay. Whatever. So basically, you have to play against the other opponents and you have to score good. And similar to chess, they'll have a rating system where you will be rated against on the time number of wins, number of losses, and that kind of stuff. So makes sense. And then finally, at the submission deadline on March 2, additional submissions will be unlocked. Blah blah blah. Classic stuff. Prizes. Yeah, if you care about that. Let's see. For documentation on the API, see this document to get started on developing a pivot. See our GitHub. We are always looking for feedback, bugs, and if you find any issues with the code specifications, please ping us on Discord or on GitHub issues. We'll be fixing clear, clinical, blah blah blah. Background with help us 600 plus. Okay, you have already explained that. Yeah, let's look at the environment. In the Lux AI season 3, two teams compete against each other on a 2D map in a best of 5 match sequence called a game, with each team match lasting 100 time steps. Both teams have a pool of units they can control to gain points over the map while trying to preserve the other team from doing the same. Unique to Season 3 is how various game mechanics and parameters are randomized at the start of each game and remain the same between matches in one game. Some mechanics parameters include the map, terrain, generation, how much units can be placed on the map, and how might be blocked on the map features. Each match is played with a fog of war, where each team can only see what their own units can see, with everything else being hidden. Given that more mechanics are randomized between games, the specs will clearly document how they are randomized and what the possible values are. There is a summary table for every parameter. Okay. Balanced strategy of exploration and exploitation. It is recommended to explore more in the first match or two before leveraging gained knowledge about the map and opponent to behavior to the later matches. Okay, so we need to dynamically explore and exploit based on the opponent's strategy. Somehow, if you integrate that, that will be a very plus point in this one. But okay, the map is randomly generated 2D grid of 24x24. There are several core features that make up the map: empty tiles, asteroid tiles, nebula tiles, energy nodes, and relic nodes. Notably, in a game, the map is never regenerated completely between matches. Whatever is the state of the map at the end of one match is what is used for the next match. Okay, so the state remains same. So if you know from the first map that your relics are there in a particular position, you want to explore the relics, right? Whoever finds the most relics, then you have a benefit. Okay, there are empty tiles in space without anything special about them. Units nodes can be placed or move onto these tiles. Extra tiles are impassable tiles that block anything from moving spawning onto them. These tiles might move around over time during the map in a symmetric fashion. Sometimes extra tiles might move on top of the existing units in the game. The unit is not removed as a result of this and can still take actions and move around. And there is a non-extra tile adjacent to it. So you're saying that asteroid tiles will move around in a symmetric fashion and in the game unit is not removed as a result of this and can still take actions move around provided there is a non-asteroid tile adjacent to it. Okay. Possible tiles with number of features. These tiles might move around over time during the map. Vision reduction. Nebula tiles reduce vision block. Okay. So how does the team vision affect me? Not really sure. And tiles can reduce the energy of units and then end of the turn on them. Okay, energy nodes are mysterious objects that emit energy fields which can be harvested by units. In code, what actually occurs is the game nodes are randomly generated. Okay, relic nodes is the object in the space that enable ships to go near it to gain points. These are relic points, however, are ancient and thus fragmented. As a result, only certain tiles near the relic nodes, when a friendly ship is on it, will gain points. The relics that yield points are always hidden and can be discovered by trial and error moving around the relic nodes. On it will gain points. Positions themselves can be observed within sensor range. The tile around relic nodes can overlap with the tiles of other relic nodes but will not yield extra points if that occur and is treated as one tile. In code, a random 5x5 configuration mask centered on the relic node is generated, indicating which tiles yield points and which don't. Multiple ships can stack on one tile but will only yield at most 1 point per tile. Note that ship stacking can be risky due to sapping action. See sap actions below. The sap action lets a unit target a specific tile on the map, which is called the param.unit sap reduction, and reduces the energy of each opposition unit on the target by param.unit sap cost. While oh, there's a lot of detail in this. Okay, let's not try to take in all of it for now. For now, the simple thing is we need to be, yeah, let's try to do it in an organized fashion as such. I don't know why I have to do all of this. Um, but okay, so problem description wise, whatever we have understood till now is that it's a multi-agent game where being closer to the relic tiles gives you points. This is how you get points. The second detail that is important is that um, there are some constraints on number of units and their energy block gives units energy. Asteroid nodes can tiles. Asteroid tiles can block your motion. Im Impossible. Wow, very close to impossible. Sounds cool. Cool word. Yeah. And what else did we learn? I think that is fine for now. And also, like it's a 24x24 map. And I think that's majorly it. And we can see relics in range of the sensor and nebula tiles reduces your vision. So I'm not sure how, but I think we'll figure it out once we go through some code and try to make our own bot and see how it is performing. I think that will allow us to learn better. That's Sometimes you can get stuck in trying to understand the problem in too much detail at the initial phase and not really build something, and then you will feel like, oh, it's too much, and you'll try to give up or something. It's better to start slow, build something, and then we can continue focusing on how to actually solve the problem, how to understand it better than the notebooks that we have just read. So, okay, I hope that makes sense. Now let's start formatting this for God knows what. I'm not even working on this, but yet, so okay. So let's start with a public notebook, right? So I have opened this notebook here. So let's see what it is all about. Assume that you have a basic knowledge of programming. It's okay. If you don't know the game specifications yet, feel free to always refer back to docs on GitHub. We'll open them in the site just in case we want to see in detail time to time what we are actually working with. Basic setup. First thing is you have to verify 3.9 or above and have the Lux S3 package installed. Run the command below to do so. If you are using Kaggle notebooks, make sure to run. Also click run, restart, and clear all sellouters on the tab to view. This fixes bugs. Okay, makes sense. Then run the following command line to verify installation works. You didn't tell how to install this. Oh, okay. Yeah, okay, so let's try to build our own notebook using this. It will mostly be copying and pasting code, but we'll not directly control C and control V. We'll try to understand each and every line and see how we can write it as well. So let's create our new notebook. Competition data set. Okay, do we have it? Remove it? No. Add it. Cool. We have this. Competitions. Do we need to have something from here? Kit utils package. I think that will be needed for us later. Let's quickly remove this and just do. First of all, let's install this package. I don't think we'll be needing GPU for now, so I'll avoid using a GPU runtime. I don't think we would have a. Where do we see vision metrics? Yeah, this is a non-accelerated environment, right? Cool. We don't need an accelerator right now. We'll need an accelerator once we decide on which model we are actually using and how are we training it. Then we'll be able to see how we can parallelize that training. We can also see if we can use stable baselines 3 in here or something. I have to check if anyone has presented a notebook on it yet. Well, I don't think it doesn't really matter, but it will be helpful to have a notebook. So this is the official notebook, I guess, or no? No, I guess not. Let's just look at the code. Is someone using stable baselines 3? No. Okay, very few notebooks published till now. Let's see if we can do something about that. So this is the one we'll be following for now, I think. This is one we have, right? Stone Tower. Okay. Heuristic logics added. We can see through this just to get an idea. One more starter notebook copied from. Okay, this is working ahead of Stone Tower, I guess. Okay, we can see through this as well. Any other notebook? By Python Stemmer. What is Stemmer? I've never heard of it. See, this is the advantage of working on Kaggle datasets. You basically get to work on problems that you didn't even know you would want to work on. But there you are working on it because of competition. So that's kind of cool. It exposes you to more problems, and maybe you can use those concepts presenting in these competitions in your day-to-day life, in your other problems that you're facing. So that's nice. Okay, I'll open his notebook. I'm not finding any stemmer as such. I'm finding the NLP stemmers, but I don't think he would be referring to that here. It doesn't really make sense. Lux AI creating agent. Okay. Okay, I think that should be all for now. Let's see what all we can do with these notebooks. And by the way, Ducky, we'll have him in the background from now on. He's a cool guy with a watch. So yeah, cool guy. Just wanted to let you guys know. So okay, let's start with this notebook. So for we have installed our Lux 3 agent. Let's quickly check if it is working or not. Okay, we'll have to wait. We are not thrown any error yet, so I think the Python script has been installed correctly. That's good for us. But we still got an error. No module named. Okay, let's just restart it and see if the installation worked or not. As this guy has just mentioned here, that it is good to restart because sometimes there is a bug where Kaggle notebooks load up an incompatible package. So let's see if it is installed yet or not. No module named IPDP. What's this? And why didn't Lux Season 3 install it itself if it was a dependency? That's stupid. Okay, I'll install it then. Annoying. I'm gonna copy these instructions because sometimes the name is too close and then you fuck up. Oh, you don't even need to use an exclamation point in Kaggle. That's nice. Okay, installed. No, you may need to restart the kernel after using the package. Okay, I'll restart it again. Thank you. Is it working now? Good, it is so slow. I think I should make a offline session for this. Okay. What the hell is IPDP though? Is it some kind of a exports functions to access the IPython debugger, which features tag completion, syntax highlighting, better tracebacks, better intersection with the same interface as PDB module. I've never used PDB. So it is basically a debugging module that allows you to run debugging in your notebook itself. That's nice. But it is still not working. Make sure to also click restart and clear sentences at the top right, blah blah blah. To run this, do this, and you can upload them on there or you can play them here, I guess. That is your match replace, and it is stuck for some reason. I don't think it has moved forward any bit yet, or what even is that it is processing. Nah, it doesn't seem to be working. What should I do? Stuck here. Has anybody mentioned about this? I got the errors from direct to why my package is not in the notebook. We modify the system path of where to look for modules. Make sure to run that. It's at the top file where it runs the pip install code. I'm missing something. Show hidden cell. Okay. Okay, let's do it like this then. I think I'm not even sure what can give an error here. But something is, so just to be on the safer side, let's delete this, restart our session, and let's go ahead with this code. The request duplex members must be specified with the request streaming body. What the fuck is Kaggle even throwing at me right now? But okay, so whoever has been just joining in, we are working on the Lux AI Season 3, and I think that was clear from the title itself. Our goal will be to read the problem description first, go through a starter notebook, understand what the problem is, and then we'll start working on our own creative ideas and exploring some experiments. And while you are here, if you are also yourself looking at someone to work on this problem with, leave a comment below. We can make a team or we can just experiment with the ideas that you are presenting and have some interesting things going on. I'll be mostly making all of the notebooks I'll be working on during the live stream public, and see if I will be working on in the background on the task to get a better rank, because why do you want to do Kaggle if you don't even want to satisfy your alter ego with a good rank, right? So that's a good target to have. No problem with that. No one will judge you. Everyone is here for a rank. So yeah, let's get ahead. So currently we are following this most voted notebook on the Kaggle competition for this basic problem, and see, let's see what they have done, what the problem is all about. We have read through the description, didn't help us much. Let's see if this does us any better. Okay, so finally our code is running now. I guess pip install upgrade was the different thing they did. That somehow helped. And media agent and copy this. I don't think that will. Okay, maybe you need to import that first. But let's see. So now you will be able to see a basic game, right? I think for now the agent that they have provided implements some basic, what do you call that? Uh, Basic random move generation or something. Yeah, np dot zeros for invisible nodes. If I underscore delete nodes. Is there? Is that their original agent.py? That's interesting. So they've already provided it with some, like there is definitely randomization, but it is only if, okay. So let's see what the agent is doing first of all. This should be one of the first step. This will go under this section where we are exploring the GitHub game environment. So basically their agent, you give it a player, you set what player name is or whatever, team ID, doesn't matter. So this is for a single agent. We'll be having multiple agents in our game. And when you act, you ask it to unit positions. You get all the max relic units divided by 2. So you get all the positions for your units and the position for your relic nodes. I think only the visible relic nodes must be visible, like available in this list, otherwise there'll be no point. And you mask it through that. Okay, team points, whatever, and then unit mask is okay. So you are basically filtering out all of your available unit IDs. Then visible relic nodes, yes. So whatever are your observed relic nodes, from that whatever is visible there is your visible relic nodes, and then you take an action where you set whatever your max. Okay, so your action is your total number of units, and you can have 3 different actions. I think that's what it means. Basic strategy here is to simply to move, have some units randomly explore and some units collecting as much energy as possible. And once a relic node is found, we send all the units to move randomly around the first relic node to gain points and information about where relic nodes are found and save them for the next match. Save any new relic nodes that we discover for the rest of the game. Okay, so you're saving that, got it. And then you're saying that basically relic node positions, you want to append your observed relic node position ID, so you'll have them all saved, their all positions. Got it. And your for units in available units, you get its position, you get its energy. If it is, yeah, if you have find a relic node, if you have a observed relic node near you, you search for the nearest relic node position and you calculate the man-at distance from that. If your distance is less than 4, then you randomly move around that. Okay, so from 0 to 5, so you're basically randomly moving in the 5 tile area to that 0 to 5, so 4 distance you're moving around that relic node. Else, okay, I get it. I'm not sure how they are defining position. If they are defining a random integer from 0 to 4, does that mean that you will go in one of the 4 directions? Or like, what is this? Random direction, comma 0, comma 0. Actions unit ID is equal to random direction. Okay, I think 0, 1, 2, 3, 4. But why would you need 4? It should be only. And both of them are included in randint, right? As much as I can remember. np.random.randint. Is it both inclusive? Hi, exclusive. So yeah, so 0 to 4 you are talking about. So yeah, I'm not sure why you need this. I think you can also move diagonally if that is the thing. So above these 4, but there should be 4 more. So still not sure why. We'll have to see what it actually is doing. Actions is equal to unit I action for that particular unit ID. You want that random direction, comma 0, comma 0. Otherwise, we want to move towards the relic node. So direction to unit pose, relic node 0, comma 0 makes sense. And if not, then randomly select randomly explore by picking a random location on the map and moving there for about 20 steps. If step percentage equal to 20, your unit ID in explore locations. Okay, so that makes sense. So your idea should be to focus on both, like load an episode below to get started. Supports HTML and generating using this. But I have given you a file name, right? What's this? What's this then? Should I directly go to the visualizer or something? Okay, it's gonna be tricky to understand what all of this is. So I think those are my agents. 0, 1, 2. Oh, we got up a unit. How are they increasing the number of units? That's weird. We should have a fixed number of units, right? Or is there some kind of logic to that as well? So yeah, these kind of details we'll have to focus on. So you get your number of units increased. Your, I think your, this region is whatever is visible to you, and the yellow dots represent your relics or something. Okay, I'm not understanding a lot of it. But that's what we have to do. We have to understand it. That's a task we have taken up for us. So, okay, so this is what we have for some reason. I'm not sure what represents what for now. I'm building an agent. Now we know that our environment looks like. Let's try building a working agent. The goal of the environment is to win a best of 5 game, where each match is a 5 match sequence and is won by who has the most relic points. In our kit, we provide a skeleton for building an agent. Avoid removing any function from the kits unless you know what you are doing, as it might cause your agent to fail the competition. So this agent definition should be stored in the agent.py. The agent will have self.player, self.opposition player, self.environment configuration populated with the correct values at each time step of an environment during competition or when you use the CLI tool to run machines. Stores the environment configuration, self.player, blah blah blah. Okay. So this is your agent function that we just read, I guess. It should be very similar to that only. But let's go through this again. I'll close this up and let's see what we have. So we have an agent, you have a player defined, you have position time defined. I think all of this we don't need to worry about. The initialization would be taken care by them. And now what we have to do is you're getting your unit mask wherever your unit is, you're getting your unit positions, you're getting your unit energies, and you're getting your observed relic node positions, observed relic node mask, team points, available unit IDs, okay, and actions is equal to np.zeros. So actions is like this because again I think that, okay, so you can take maximum number of units and your zeros. So you have one of the 3 actions available, but you should have ideally 4. I'm not sure how the action thing is working out right now. This is something that we'll have to explore. So okay, so what is this? This is the evaluation function. So there what they are doing is Lux AI gym environment and record episode. So evaluate agent, you give agent 1 class, agent 2 class, seed or whatever, and okay, saved AI environment record. I think this might be a bug here itself. This should be agent 1 class or agent 2 class, otherwise there's no point in taking those inputs, you are not using them anywhere. And that's why it's annoying to code on Jupyter Notebook. You know, you from the color matching or the color highlighting that you get on on your VS Code or something, it is good enough to help you a lot in cases where you can't seem to figure out what you have to do. And that is something that you are not able to take benefit of when working with Jupyter Notebook or Kaggle notebooks in general. So it's better to work on code itself. But okay, so somehow the shift enter is, why is the shift enter not working? I'll just restart this. I mean, I shouldn't have factory resetted it, but bro, what the hell? Bug? Okay, guys, we are facing a bug now. I think this calls for setting up a local environment only. This is not working out for us. Yes, so let's just download the whole data set and see how we can work with this in our local machine. So I'll just go to my projects document, and this will be in Python mostly, I think, and Lux AI season 3. Let's go. So let's save it down here. Just avoid all of this. Yeah, this is where you are, right? Cool. So let's set up our VS Code. Cool background though. See it? Looks very pretty, very encouraging. Cool. So let's see what we can do with this. We'll open up our, can I see what thank you. And we'll go to our projects, and we'll go to our, let's say, season 3. Let's go. And also let's extract it while we are at it. Okay, you can't do it like that. Shit. Open it up. Go to my file manager, document Python, and Lux AI. Come on. Extract it. Cool. Now let's see what we can do with this. So yeah, what do you want to work with? Do you want to work with a REPL file or a IPIM? I'll prefer a REPL file myself. So yeah, it was just a trick question. Your answer doesn't help anyone, but okay. So let's set it up. First of all, let's set up an environment. I've been using the UV environment for a long time, and I think it is pretty good actually. Again, the naming will fuck us up a little bit, so I'll just close it for once. Open up my file editor. So UV, the thing is that you can't name things with spaces in them. You have to use underscores and stuff, and I always seem to forget that. So let's just call it Lux AI season 3. And let's open it up again. Kind of annoying to do it like this, but you know, you have to sacrifice something to get something, and UV environments are good. You know, you get the project.toml file, you get it cleanly. It's not like poetry where you have to figure out a lot of your project.toml file, which can get pretty annoying pretty quickly. But yeah, so let's focus on this project. And now we are ready with that. Let's open this up. Open them side by side. Bring your friends in, guys. Come on, we have to form a community here. If you will not form subscribers, you will not get me views. Why would I do this? You have to commit to something for me to commit to it as well. You know, it's a mutual thing. Figure it out. I hope you are clear with that. Cool. So yeah, first of all, setting up our environment. Let's go clean UV init, UV add, and we'll go Lux AI season 3. I think that should be all that we need. Make dir agent and CP blah blah blah. I don't think we need this, right? Okay, if we even do, let's do it like this. So yeah, if you can just quickly install it, thank you. UV, you are supposed to be fast. Don't be fucking slow with me. Make dir agent and cp-r. Let's do it just for the sake of it, so that we don't face any errors, any unexpected errors. Right now, we want to solve this as cleanly as possible. And everything agent. Cool. And then we'll go here. We'll start writing our code. Import sys.path.append. What's the difference between append and this? I think you can just do append, right? Why do I specifically want that in the first position? That doesn't make any sense. Yeah, it will not. Let me do it like that. uv add app kernel. And cool, you're all set up. Run this. What's that supposed to mean? Are we not using the correct notebook? Yeah, we have to use this, right? And now it is working. Cool. So here we have it. The environment is all set up now. Do we want to test it? Let's just test it. Why do I have to write it twice? That doesn't make any sense. What kind of CLI is this? Agent main.py. Okay, so you're providing two agents basically. That's what you're doing. Okay, that's good. This will allow us to quickly train some. Yeah, I have not. Now it should work. Yeah, I already activated boa. Let's quickly get our replay.html, please. If you can really do that for me, that would be really cool. Wow, it's so slow. And well, how the fuck did I mistype replay? It's reply now. Fucking annoying. Such a OCD thing. I'll keep seeing reply here. But okay, we don't need this. We'll be opening a live server from VS Code itself. Let's quickly go to building the agent part of things. What's this now? Okay, that's what I expected. So we'll just open it with our, oh no, that's not what I wanted to do. Open with live server. And cool, here you have it with this big display, all clean, all pretty. Nice. So we'll have it here now. I think that's a pretty good setup for this competition. Clean and everything. Let's just shut down our files for now. Taking too much space on our 13-inch small laptop. It's pretty small, but we gotta live with this. And we imported our packages. Let's define our class agent. So let's see what all there is in it. So I think this is their. The agent class below is a minimal code sample of something that takes 0 actions units do nothing. Okay, the agent will have these things. Now that we have our environment, look, let's look at a working agent. The goal of this environment is to win the best of 5 games. I don't think we need to build this agent, and this is just to try see the sample. And so you don't want to play with anything here. You don't want to basically modify anything. All you want to do is append to the things that are already there. You don't want to create any new. You don't want to play with the names or whatever they have used already there. All you want to do is basically do some actions. So yeah, a little bit off my mind. Some people have subscribed. Let me just give them a quick shout out if they are still here. So I've just got received a subscription from. Oh, you guys should see it anyway, right? Where's that? Ah, shit. That's annoying. No, you'll have to wait for me to tell you. Returning viewers? No, I don't want to know that. I want to know who recently subscribed. Fuck, that's annoying. How do you actually do that? I. Fuck. I'll have to do it now. I've said it. I'm not with that person. I can't give up. I can't give up. Fuck. Just let me know. YouTube, just let me know, please. Can I just know the names of those people? I know how to see it on here, but I don't want to open my ID studio when I'm at it. Ah, fuck it. Thank you guys. Thank you whoever subscribed. Thank you. We have reached our 100 million subscribe. What the fuck am I even saying? That would have been crazy if that happened. But fuck. That makes me feel so stupid now. But yes, so we have reached our 100 subscribers. We have 101 subscribers now. That's great. Keep subscribing more so that I can receive more confidence on this and we can actually start making some commitment based content. I have a lot of things lined up, but I'm just not able to commit to it as I don't have enough subscribers, don't have enough views. If you give me those watch hours and if you give me those subscribers, then we'll have something mutual going on where we can actually start working on some cool projects and do some learning based things as well. So I've recently been working on some time series transformer bullshit, and if you want it here, you'll have to subscribe, okay? So back at it. Sorry for the guys who just left because of this small disturbance that we have, where I wanted to shout out to the people who have just subscribed. Really sorry. Couldn't find their names. So let's continue starting on this. So we were building our agent. So we don't need to worry about this. This is just a basic template of what an agent should look like. The next code snippet provides a simple agent evaluation function that creates an initial environment and provides an initial seed. Then it runs a game and automatically saves replays between the replace folders. Blah blah blah. So let's see what this script is all about. From Lux AI season 3 dot wrappers import Lux AI gym environment and record episode. Def evaluate agents. You want to provide your agent 1 class and your agent 2 class. Seed whatever. We don't need that. Let's keep it as none. Or just for reproducibility of the code, let's keep it like this. Games to play is equal to 3. Replace save dir. Okay, so what it is doing is it is first creating an environment with the record episode. Lux AI Gym 3 agent, numpy output true, save on close true, save on reset true, and finally save dir is equal to replay dir. Okay, so we are using some pretty standard information. This is again as your stable baselines 3. Not basically stable baselines 3, but this is a gen environment that can be easily used with stable baselines 3. So our progress in this would be to first create a basic game and understand what all is going on in terms of the environment variables and in terms of what we actually need to perform, and then maybe we can work on our stable baselines 3 based RL model. That's exciting. Environment configuration, info params. So okay, so why are you resetting it twice? You don't need to, right? This one is just a waste. Then yeah. Okay, fixing the code as we go through it. Nice, nice. So player 0, agent 1 class, player 0, environment configuration. And you're getting the environment configuration from where? Okay, info params. Okay, got it. And then your player 1, give it the environment. Finally, game done. So we are creating a loop for the game here. Actions is predict for agent in player 0 comma player 1. Let's see how the agents actions are getting used. I think that's the most important part. So actions agent dot player is equal to agent dot act. Step is equal to step comma observation is equal to observation agent dot player. So you get the action out of it, and then you say observation reward terminated truncated. These are all pretty standard things that you have to return from a genuine environment, not necessarily useful as such, but yeah, you need them. Dunce is equal to terminated comma truncate. What is that? Okay, so you're just basically calculating the whatever duns that we have, how many of them are truncated and how many of them are terminated, I guess. That's all that you're trying to do. So whatever the situation was, what is it, truncated or was it terminated? But you're taking a or between them, so it doesn't make any sense. What you're doing, info state is the environment state object. You can inspect, play around with it. For example, print unobservable game data that agents can't see. Okay, that didn't help. Fuck, can't you scroll in this? Unobservable game data that agents can't see. Okay, so if any of the player is done, is the game done? Both of the players should be done for the game to be done, right? Or does it just mean that whoever move it ended on? I guess that would be it. So this is for now we have not done anything much of ourselves for now, and I think if you are not able to understand something completely, this is the cleanest way of doing it. You first wanna actually understand that what is going on without worrying too much about if you're not able to understand it or anything that will stop you from actually working on the problem, and you definitely don't want that. So you close the environment after the final replay, and you do step plus equal to 1 there outside of the for loop. Okay, so you get the actions for both of the players, then you get this. Okay, a little bit of a bug there, but now it's fixed. Yeah, so you get both of your actions and then you send your actions directly. This is the format it is expected in inside your environment, I guess. And yeah, then you will just find out your number of truncated and terminated. I don't think that matters. Duns player 0 or player 1. So K was in your, K should be in your, Duns is equal to this, but how would your K be in this then? I'm not really sure if this code will work or if it is a bug. Let's see. Evaluate agents. Yeah, and we just wanna agent import agent. No, not that. There was an agent dot agent import agent. Yeah, this will work now. So let's see how well we are getting right now. So let's restart this, clear all the outputs, and run through our REPL file. What the fuck is the error now? How the fuck can you not find a module name agent.agent? It's literally there. I think it's not registered as a module. It's wanna. Yeah, this should work now. So let's restart this because it will not work anyway right now. Guys, where are you gone? You gotta come back. I was just trying to give some of the subscribers a shout out. You don't have to leave me like that. Okay, so we have the replace saved in our replace directory. There you go. And what you can do is, I guess, go to your home, drag a file to select. I want to do this every time. I thought would have been fucking faster, some kind of caching, but here you go. You open your JSON and boom, you get your game. And now you can see what your agent is doing. So it is taking random moves. So I think after every few moves, a new agent is generated, or a new unit for that case. And okay, so 2 units are placed on that position. Now 4 units are placed on that location. So this guy is the one who is exploring randomly, and fuck, they have reached the relic nodes before us. Oh, what the hell is happening? I hope the yellow ones are the relic nodes, otherwise I'm just being stupid. Okay, okay. Bro, how much units do I have? It's crazy. Do I keep getting units or what's happening? I think the purple, these ones are your relic nodes. So, oh sorry, your asteroid nodes. So what has happened is on the asteroid nodes, your game has been stuck, or they are not able to move anywhere, like the random move generation or something, or maybe the focus was on these nodes, and I think the energy for these units must be decreasing by now. Player B, who is player B and who is player A? Okay, so player A is winning, right? Because they are on top of the relic nodes. Okay, but there are a lot of red ones here as well. I'm not sure how that is working. Whoa, whoa. Did they? How the hell did the red one hit the blue nodes? And the points are 0 now. What the fuck was that? Yeah, I'm still not understanding the game enough. Fuck. That we have some agent that can be run. Let's add some logic to the agent that it can go and explore. We'll use a basic strategy of sampling a random location on the game map and have the units move there until it reaches the location. I mean, what else can you do? This all we have already seen. This is exactly what the code is on there, I guess. Let's quickly check it out. So you have your self.player, self.team, blah blah blah. This was already there. Now this is your unit's explore location, unit relic node positions, and discovered relic node IDs. So this is to basically store the positions in the longer format because you have multiple matches and you can store this information from one match to another. As you know, the position would be exactly the same. The only point is that the asteroid location can change. So your path to the relic node can change as such. And I'm not really sure if reaching there first is a concern or making more of your units go there so that the other units are like their value is degraded is what we want here. Is this. But okay, so you have all of the things that we did before, and you have your visible relic nodes. You go through all of your visible relic nodes to find the closest one. When you have your closest one, you, if like it is in your, if a relic node is visible at all, then you try to move your locations closer to the relic node. If the relic node is less than 4 Manhattan distance away, then you keep randomly hovering over that place by doing this random direction selection, which I'm really not sure how it's working out. And then if you're not there, you move your units towards the direction to the nearest relic node. That's the whole idea of this game. And yeah, if you don't even see a relic node yet, what you want to do is you want your unit IDs to explore locations. So you randomly pinpoint a map location and try to move your some of your units there so that they can see if there is a relic node available, and people will go to there, find those locations and work out. So okay, so the basic agent logic is understandable now. The only problem is how to actually work on improving this. So yeah, I think this made sense. And for submission, you have to just convert your agent file. So the same agent.py file that we have here, you just wanna, oh, you wanna submit the whole file, is it? CD into the agent, and this agent folder has everything that you need. So your main.py, readme you'll not need in our case. So you replace this agent file with your own agent file, and rest everything will work automatically. Just remove this .init.py, I guess, as there might be some problem with this. Running OS fork is incompatible, and then you finally submit. And before submitting, you can check if your agent is working or not using these commands. So let's do that, because I think we have not changed anything on the agent side, but just to make sure that everything is working, we can quickly do that just to understand what we want to do in these situations. So Lux AI season 3. One dash o replay.html. Must provide two paths. I did provide you two paths. Did I not? Why do you think that? Oh, okay, I've provided more than two parts. For the fuck am I smoking, bro? How the fuck does this happen? Okay, it's running now. Cool. Then we'll finally get rid of this stupid reply.buffer. And we'll go to replay.html, which is the good thing, with no spelling mistakes. So yeah, so we have our replay here. Everything seems to be working, and this is what you have to do. So simple as that. You have to create a, you have to load up these materials. You copy the Lux AI season 3 into whatever name you want, and you want to create it as a gz file, tar.gz file, and then submit that basically. So super easy. Submission.tar.gz, where you will store all of the file inside of your agent, and that will basically have your Lux, whatever that is, your kit and utils. Your agent.py agent will have your direction to function, or you can have some more functions from the lux.utils. I guess we'll have to explore that a little bit more. And you have your main.py that will actually create your replays and run the game for you. So major focus gonna be inside the agent and inside the act tool. And if you want some kind of a variables that remain for a longer duration inside of a game, then you want to allocate them here. But again, you have to extend the code, not modify it. If you edit the code, you can fuck up, and your submissions might get a problem. And you only have 5 submissions a day, so you don't want to risk fucking up one of your submissions at all. So we are clear on the starter notebook. I think we have some idea about what the game looks like and what all you are trying to achieve here. And we have a gym environment for the game as well. So it would be interesting to run a RL model directly using stable baselines. We can even benchmark using that to see if we train a naive RL model using the reward system that might be already implemented inside the game. Would that be enough for us to actually show some improvement? So let's see if we can do that in stable baselines 3. uh, multi-agent RL. Environment consider different agent without of the for actions is important. Is there a way in stable baseline 3 to train by step instead of train as whole? Well, one more problem that you have here is hello Sid, what's up? Which Sid is this? I have many Sid friends. Fuck. Is this one of my Sid friends, Sid, or is it some random Sid from the internet? But yeah, so what I was saying was that in stable baseline 3, the only problem is that you want to store these kind of variables, so you have to integrate them there. Oh yeah, I think I do remember you. You were you in that stream? I think I remember you from the MLX stream or something. I'm not sure. MLX or O1 stream? Not O1. Not O1 for sure. I don't know. Maybe O1. Fuck. Bad memory, bro. But hey, good to be have you here. How are you feeling? Yes, so this time we are not working on a LLM problem. We are working more towards what is it? Like I can't really call it a RL problem because you can formulate it as a RL problem because you have a gym environment and everything. But I'll call it more of a just let's keep it as a Kaggle competition and problem for now, and we'll see which model works best for it. By the way, for that RLHF, what do you want to learn on RLHF? I think there was some good things regarding RLHF recently. So OpenAI has started this beta program in RLHF. So yeah, so you can basically sign up here and you will be able to train your model that whatever you're using, like what are this 4.0, 3.5, blah 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 blah. You can train it on your reinforcement learning based models. For example, if you're working on a product, if you're working on something particular, what you can do is you can try to have a front end where you have two answers at the same time, just as GPT used to have at the initial stages, and then your subscribers can select like resources to RLHF and reasoning for OSS models. OSS models, open source. Okay, yeah, we can do that. We can, okay, that can be one of our next projects. Like, we'll take a while for it because okay, so let's say if we want to train our somewhere for something, for example, 5 3.5, which is a open source model, we can try to make a project where we have a front end developed, where we'll see both of the answers generated, and you will have someone in the loop who will select the answer, and from that the model will keep learning on the fly. So you can, yeah, that will be a nice project to open source it basically, and like you can play around with this. You can put in any model inside of it. Your model will get some results. You will be able to tell which one you prefer, and if you are working with a team, if you are working on a project, then your team can work through it and will keep it as a parallel process so that everyone can train the model with their own preferences. That's nice. That would be a good project, actually, really helpful. Yeah, let's do that. Good. That will be our next project, next live stream. You're gonna get that maybe tomorrow itself, we can see. But today we are going to be working on this Lux AI season 3 problem. Okay, that's the schedule for today. Also, yeah, did you see that stream on that document query engine that we were working on? But yeah, so okay, I think this notebook we have gone through enough. We understand what all they tried to achieve here, and now the idea would be to work with the stable baselines 3 engine to have a benchmark. Oh, okay. So in that project, I'm basically taking a problem where, so if you have heard about Dockling is a recently released open source framework for documents, and it basically does your document processing for you. So it is released by IBM, and if you put in any of these document formats, you will get it in a clean JSON or MD format, which is more understandable via LLM. So I was working on this. I also recently made an open source contribution on it, and finally got my name in the contributors. Let me just flex that up a little bit. So yeah, so the basic idea was to work with this, integrate it into a pipeline, and use some better OCR methods with it. There are some gaps in it that we can try to fill up, and then have it as a single pipeline with the Gemini API that has been recently freed by Google. So it's free of charge now, and we can use it to have our document query engine that can take up any document and run query on it. So yeah, got my name in the contributors. Cool, exciting. Finally got my pull request accepted. It took a week. Took a week. But yeah, that was a cool experience. But anyway, so we're working on this model, and the idea is to create a clean front end where you upload your document, and if it is a larger document, we can also work on things like your normal RAG or your graph neural network, which I'm heavily interested in because RAGs are kind of a loosely held topic. So the problem with RAG is, let's just go in that direction for a bit. When you, so this is something that I don't know, and that's the interesting thing of Kaggle, that you don't know what you're working with, and when you're working on something you know more, you have to able, or it is easier for you to talk about that. So yeah, let's just quickly deroute a little bit and talk about what the problem is with your basic vector embedding based RAG models. So when you run on RAG, so for example, you're asking a RAG model that what happened in 1989, right? Your document has, you upload a document, you create a vector embedding out of it, you do your chunking. So this is the if you are aware of the standard pipeline of RAG models, so you have your documents, you process them, you chunk them, create embeddings, index them, and then finally you just retrieve your embeddings based on vector store comparison, based on the query that you have just generated. Now, in the biggest problem with your vector-based embedding retrieval is that when you're asking a LLM model that, hey, what happened in 1989? What will your model attend to? Will it attend to 1990? Will it attend to 1988? No, it will attend to any year it will see. So it will attend to 2003, it will attend to 2004, it will attend to 1920, it will attend to any number basically, because these all numbers would be really close to the embedding space, and it is not necessary that 1989 will be closer to 1988, 1990 than 2003 or 2004. And this also gives rise to hallucinations, because if your document don't have this year, your LLM will still talk about random years that will come close to it, and it will not say that I don't have any data about 1989, and you are stuck with the hallucination problem. It's not working in production, you are fucking annoyed that you are not able to commercialize your RAG project. But yeah, that's the problem. Then comes in graph neural networks. In graph neural networks, you create a graph based graph data structure for your documents, very similar to this, only so not much of a difference in terms of the pipeline. So you get your documents, you uh, process them, then you chunk them, then you create embedding as well. But at the same time, you are also creating your what do we call them, NER, named entity recognition, not exactly named entity recognition, but you call it triplet extraction. So you are extracting your subject, let me just explain this, subject, uh, action, and object pairs. So you extract them, and then you find the common actions, common objects, and then you create a graph out of it. So your closer actions, a group of subjects taking the same expression, like I'm dumb for GNN after chunking, and it hits how it's different from RAG. Okay, sure. So yeah, so you do your documents, you process them, you create your embeddings. So you, for all of the chunks, you have some vector embedding with it. But at the same time, you're not stopping at creating those embeddings. What you're trying to, embedding is also an optional thing here. Let me explain you why it is optional later. We'll come to that part. and why do we want it as optional? Because as I just discussed, your embedding is your main problem, right? Embedding doesn't work on synonym, it works on closer things. So one more example that will help you understand this is, for example, if I ask that who was the king, or if I ask who was the, and in my text the question is the ruler of that century was King Arthur or whatever, was Arthur. Let's not, let's say our document is this, and it also has information about, and Queen was Elizabeth. Now the problem that you will face is this is a different chunk and this is a different chunk. And when you ask this question, who was the king? Now queen will might be closer to in embeddings to king than ruler, because ruler is more related to your scale, your like measurements thing. There might be more things about the document in that, and ruler therefore has been put closer to your measurement side of things, and the king was put closer with the queen. Now when you ask the question, you will be answered Elizabeth and your answers would be fucked. So synonym based embedding versus vector based embedding, this is the kind of problem you face there. But yeah, coming back to this, I'll explain why the embedding part is different. You can even remove this for now. um, let's put a Python. What the fuck? Okay, no. So yeah, so what you're trying to do after chunking is that for each chunk that you have generated, you are trying to find subject action object pairs inside of your chunk itself, and one object can have multiple such pairs. So your subject is, for example, a person, a noun, any particular noun you can think of. Action is a particular verb that the noun is doing, and the object is the thing that the another noun that the object is, like the subject is using for their verb, right? So this is your triplet. Now when you send a paragraph to this model, you'll get all of these different triplets inside of it, and you try to form a graph out of these triplets. So you have this pairing that subject leads to an action and that action leads to an object. So this is your particular like node structure, and you can have common subjects, common actions, and common objects. So you'll be, after you process the whole document like this, you'll be rendered with a whole big graph that has all of these subject object action relationships, right? Did it make sense to you till then? Is the triplet extraction part clear? So you get the graph data structure out of it, right? So once you have this graph, what you're trying to do is, uh, one thing that a graph allows you is to find things that are closer in relation to each other, rather than just like here you were just getting things that were closer semantically. Not even semantically, I'll say more in terms of there is some semantic logic behind the embeddings, because this is what the embedding is also created from large language models. But again, the problem is that you will get more of the semantically close things rather than the synonyms. So synonyms can get messed up, and ears and stuff would be completely messed up every time. So your hallucination numbers would be crazy. Now coming to this, you get your graph data structure out of it. Now one thing you can do here is, first of all, you get uh, so what you can do is, like once you have a particular object extracted, whatever people have taken the same actions, or you can like traverse the node in a particular depth. So for example, if you get a particular subject, and from your question, so you asked a question, you applied your triplet extraction on the question itself, and you identified a subject. Now you're searching for this subject inside of your graph data structure, and you run through all of the nodes in a two depth, I guess. Okay, fuck. I think I'm not explaining this too well. Uh, okay, let's see. Let's take an example. So Ram eats cherries. Shyam eats bananas. And you have another thing. Ram does jogging. And Ram is healthy. Shyam is unhealthy. So this is your data structure. This is the subject object relationships you have. So this is basically your corpus of text you have generated till now. And you want to use this to answer a particular question. So you want to say that why is Ram healthy? So wow, why is Ram healthy? So once you receive this question, you will not want to do the vector embedding relationship that you were finding earlier. Rather than that, you will find the subject, object, and action triplets inside of your question. So for example, in this question, I'm able to find Ram and healthy. So I'll go to those nodes inside of my data structure, which is my corpus of all the document, all the context that I want to provide to my LLM. And I'll do a depth first search inside of it on a depth first search, or maybe breadth first search, that you'll have to figure out. I think depth first search will make more sense because you want to go to subject, object, subject, action, object, then object, action, subject, some kind of things that will traverse along those lines. And so here you go to Ram and you go to healthy. So you receive to Ram, you receive healthy, and then you do a depth first analysis for a depth of 2, let's say. So you get Ram does jogging, Ram also eats berries, and Ram is healthy, and healthy is related to Ram itself. So now, instead of doing that vector based thing, now your LLM will receive all of these information that Ram eats cherries, Ram does jogging, and Ram is healthy. So when you are finally answering the question, you will have all of the details that Ram eats cherries, he does jogging, and he eats healthy. So that's why he is healthy basically. Oh, is that? Yeah. Is that? I didn't notice that. Is that visible now? Yeah, there's some lag. Okay, cool. So yeah, so that's a trick. So you will get all of this information, and even though if I had not used RAM in here, for example, if I had said that uh, cherries leads health. So you will go to Ram eats cherries, cherries leads to health. So even though your cherries was not a part of your context, your LLM will be able to attend to it, and you will get this information inside of your LLM because you did the depth first analysis on the tree. And it gets even more interesting because when you're trying to find this first node, one of the things you can do is, okay, you can go ahead and say that I detected the subject object relationship from here. Now I'll go to all of my corpuses subject object relationships, and I'll do a vector space comparison and find the first node which is the closest and do a depth first traversal from here. But instead of doing that, you can do a graph neural network based node filtering, node classification. So you go through all of the nodes inside of your graph neural networks, and you given the context that you have, and you will train a basic classification algorithm that will say that this node relates to this data information that we have right now or not. And this will allow you to actually have the nodes that actually relate to the question you're asking inside of your context, and then do a traversal on that nodes, providing better reasoning. So that's why GNNs are interesting as compared to your classic vector based embedding RAG that you do. I hope I have made it clear now. Cool. So this was about graph neural networks, and it's pretty interesting. You should check it out sometime and see if you can make a GNN based RAG. So GNN RAG is a big thing, and there was some interesting research paper that I read about it where they managed to beat ChatGPT 4.0 with Llama 7B back in the day, just using a GNN RAG in terms of a RAG problem, obviously for RAG standard benchmarks. So it's a very powerful tool. Okay, and so let's get back to our. I think that made sense. So we will be looking in that direction, working on the document query engine. That is an ongoing project. on the channel. So make sure you join in the next one and watch the previous one if you want to get the context on what all we have worked on Dockling yet. And check out my contribution if you want to. Can you see the contribution individually? I think you can, right? Um, it's not much big of a deal. I just added a okay, you can't check the contribution as such. But yeah, I just added another OCR technique. So I was experimenting with Dockling for my project, and it was a bit off stream, so you'll not be able to see how I worked on it. So I was experimenting with different OCR techniques, and I stumbled upon this paddle OCR, which was working amazingly with their pipeline and gave me the best results in all of the documents I had checked. So I just integrated this using another library, which is Rapid OCR, which provides a faster implementation of paddle OCR using ONNX runtime, if you are aware of that. So ONNX runtime is something that is used to transform your model weights into another format that can be used on edge computing and stuff. So all of this cool nerdy stuff. But yeah, okay. Let's get back to the topic at hand. So we have seen through the first starter notebook of Lux AI, and now we need to focus on working on a stable baseline 3 implementation of it. So we'll have to see how you can train a stable baseline 3 model on a multi-agent problem, because we'll have to train two models at the same time, right? And come on guys, bring in your friends in here. We need to make a community. Popularize these videos so that I can make more good content. Oh no, ducky fall. Shit, can't do that. Sorry bro. But yeah, see, he was so frustrated at you not subscribing and you not bringing in friends that he's himself fell for it. That is the level of pain we are facing here. You need to bring in your people. We need to reach more than 500 subscribers to at least start monetizing stuff so that I can actually start committing to YouTube more and feel motivated when I'm making this video. I'm like, talking to you guys is obviously a motivation. But okay. Okay, Sid, you've got to go. Cool. Just join in the stream on later if you want to explore this. But yeah, let's see what we can do with stable baseline stream. Just bring in your friends and subscribe to the channel. Don't lack off there. But okay, let's see. No, I don't want documentation. I want to use it to train a multi-agent problem. Mm, can you use it to chess? It works very shitty, right? On a two-player game, right? Mm, how can you train it for a two-player game? You need to have two agents at the same time. I mean, one simple way would be to use this default agent and train a RL on it, so you'll have a better agent anyway that will be able to beat this agent at least. But you don't want to do that. You want to generalize the problem enough so that you can at least have a powerful agent as such. Something like how AlphaZero did, right? AlphaZero, they did use a pool of expert games to at least have the starting probability, and then they used to do Monte Carlo on those top 10 moves or something. But yeah, something along those lines. For my Kala type 2-player game on my first actual project in the field, I worked on the game itself and coded a minimax algorithm. The question is, how should I proceed? Which way to create a custom open air environment? Okay, no one ever answered this before. That's crazy. Um, so let's see what we can do. Um, Should we ask ChatGPT? Would it help? Multi-agent problem. I've not seen it work for a multi-agent problem right till now. Multi-discrete, multi-processing, blah blah blah, but no multi-agent. Can't you use two agents working against each other at the same time? This is what I want to ask. So model.predict is one thing you have to do, obviously, and you do it for both of these guys. So it's maybe that's the way to train a multi-agent problem, right? You just create two different policies. Okay, so one interesting thing we can do is we can create two agents with two different learning policies and then have them a go at it against each other. So when you're sending actions, we'll basically be generating two different. So we'll have the observation as such, and we'll be generating two different actions at the same time from the two different models, and we'll have them go at each other and improve. So that should allow them to, yeah, that should allow them to learn something, right? That could be a basic benchmark at it. So we can start working on the model itself. I'm not sure if it will be that straightforward to actually train it in this stream itself, because it gets pretty tricky. And okay, so your learning was on that, so you need an agent anyway. You can't do it with a single agent, is it? Because you're using the agent here. So model.learn. Let's see if ChatGPT has something. Maybe I'm not able to find the good resources for this. So I want to train. Hey, I have a two-player game where the gameplay must be changed or affected by the moves of the opposition player. Now, how I have a gym environment that takes in as input put a dictionary player 0 whatever action comma one collection, and I want to train the two different models using different policies using this gym environment on stable baselines 3. How can I proceed? So let's see if we can have a quick dirty baseline with stable baselines 3 that go hand in hand. To train two different models with different policies and stable baselines 3 using a gym environment, it takes dictionary input. Follow these steps. Environment setup. Ensure your gym environment multiple agent actions has dictionary. Define observations and actions, space accordingly. Training loop describes. Since table-based 3 doesn't natively support multi-agent environment, consider one of those strategies. Alternating training. Training one agent will keep the other's policy fixed, or using a heuristic, swap roles periodically. Self-play with policy switching. Train both agents by swapping policies at intervals. Use vector encoder wrapper if needed for parallel environments. Okay, you're saying a lot of stuff. Dummy back environment, you have your environment, whatever, it's built up, it's ready. New custom environment, yeah, whatever, that's ready. And then you have your model 1, model 2, then you have number of episodes. For each episode, environment dot reset, then is equal to 4, might not done, action dot player, deterministic is equal to true, whatever, we'll have to see. You will have deterministic actions here, yeah. And model player 1, but I think random actions would be better in the long run, but okay. So actions is equal to this and this, environment dot set, model 0 dot learn. Can you do it like that? I'm not sure if this will actually work, but okay, I think it makes sense actually. Train them one at a time and they should go in a self improving loop. So let's see what we can do with this. So one more thing is the action space. We'll have to define the action space somehow. Oh, okay. Not actually. Fun. That's fun. That's why you use stable baselines and gym environments. That's why it's fun. That's why AI is fun. But okay, so starter notebook, stable baselines, dirty benchmark. Why it's dirty, you ask? Because we are not thinking of anything in there. We are just using it straight out of bed. Stable baselines 3. Always check your pip installs because sometimes people have very similar sounding names for them and you might install the wrong one and then you have to see what's your bug, and it's just actually that you have added the bad one, bad framework. So yeah, I've added, we are using UV for this. So UV, the best part is you'll keep having this Pi project updated directly for you and you don't have to worry about creating a documentation later. We'll have to check each and every library that you have added and test it out. You have all of this ready for you. You don't need to worry about anything. So from Lux, okay, so you'll have to do that thing first again. Where is my, I don't need no hello no pie. I know how to do hello in Python. Thank you. Start a notebook. Let's do all of this. You don't even need to import the agent. Let's go fuck the agent. We don't need care about that really. We just want to do from Lux, because we are inside the agent now, so we'll have the Lux and lux.utils. Oh no, where were we importing the environment from? From Lux S3. Okay, yeah, this is what we want. So you have your gym environment and you have this. So cool. Now we have this and then fine. Oh, okay, no, you don't have to run all of this and restart. I'll also shut this off, save some space and clear all, and see what we want to do is, let's close this up, close this. I need none of that, already flags the docking contribution enough. And let's go ahead. So let's see what we want to do is, you want your environment Lux AI gym S3, numpy output is equal to true, I guess. We don't really worry about that. So it's a basic gym environment, right? Everything works out of the box. Cool. So you create your two models, verbose, whatever, don't give a fuck about that. Record episode, don't need to worry about that right now. We'll see if it is learning or not. We'll load up our environment. And once we have that running for us, let's do this. Let's load up our environment. And then what we want to do is, you have your Lux AI and training loop. So yeah, you will load up your models. And let's see if this can actually learn something useful or not. And if it is actually even working or not. Name environment is not defined. What the fuck are you kidding? The environment name is defined right here. Did I not run this? Oh, my bad. Lux AI object has no attribute observation space. What? Does it not? Why do you not have an observation space? Observation space. Do you need to have an observation space? Uh, does it depend on the model itself or what is it? Okay, no help. They have not provided an observation space. What the hell is that? You obviously do have an observation space, right? The hell is that supposed to be? Why would you not provide an observation space? Is it here? State actions, blah blah blah. That all makes sense. That's fine. Save episode and reset. Okay. Append state, whatever. How can I get this environment space, object space? I need to provide it somehow. Okay, you have a 24x 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 24 grid, right? That's your. Let's do one thing. Let's print out our state for a second and let's see what do we have inside of it. So episode states. That's what we want to print out. That will make sense, right? You just print out your episode states or your info state. That should also help you. So let's go to our. That's why you need to have a starter notebook, by the way. And let's close this and let's go to our starter notebook. And let's run off all of these things again. Okay, not the last one. I didn't want to need to run the last one. So here I want to print the info state. Let's see what we have. Yeah, there you go. So this is basically your info state. Let's see what all do we have inside of it. Okay, you can shut up for now if you can. Okay, it's done. Cool. And numpy array map features. Oh, there's a lot of details. Okay. Should we again use ChatGPT for this? I'm feeling very hacky with that though. Unit state positions. This is all you have. Energy, unit masks, all of the good stuff. Let's just break it out on the first loop. I think this is getting too confusing to look at. And let's clear all. Boom. Now we should see only one of this object. So you have team points, you have your vision, power map, you have your sensor mask, you have your tile type. I think at max you can have. Okay, so we can make some kind of a observation states kind of thing from here, right? I mean, I can even ask ChatGPT to do it. Let's see how well of a task it does, and then we'll figure out how we can do it. Let's use the same one. So I don't have a observation space for my model. Create one from the state. Example provided below. Let's go. Let's see if it can do it for us. Should be straightforward. You have 24x24 tiles, you have two teams. Memory updated. Given your environment's complex state structure, you can proceed by encoding the state into a format compatible with Siblings 3. Here's a step-by-step approach. Create a custom feature extractor process that environment state into a flat tensor or meaningful representation suitable for policy networks. Oh, do I need to do that? No. Don't make me do that. Let stable baselines handle it. Not sure if this will work. Yeah, this is exactly what I wanted. So good. Yeah, this is it. So let's just look at this. We'll read through it and see if there's something we want to fix here. So you go inside your wrappers. You have your, where is it? Your record variable, and you just have your environment parameters. You have your action space. You just want observation space. Cool. And you just put gym dot spaces inside of it. So okay, so let's just quickly evaluate this and close this up for now. We don't want any we want to read it properly. So you have your observation space, so you have your units here, and also let's look at the chat GPT, the sample that we gave to chat GPT, so that we can at least be sure that we can match it to the input. Yeah, so first of all you have your units have, okay, so it has defined it like this. So inside of your units, you have your unit state, which has position. Position is an array of size 2, comma 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 2, comma 16, comma 2. Okay, and D type is in 16. Makes sense. Correct. And then what is your low? What is your high? No, I don't think that should be it, right? Position high. What was the high of a position and then units wise? Like you can have 16 units as max, I think, from the game design, and you have 2, comma 2. So the second two might be representing our, okay. Yeah, okay, let's keep it like that for now. We don't want any confusions and restrict the space. Energy can be, I think, what was the maximum energy? Maximum energy, you can receive some energy nodes and stuff. So yeah, let's keep the high as that only. Then you have your unit mask. Unit mask is an array of booleans of size 2, comma 16. Okay, so it basically tells you if unit exists or not, I guess, just on the 16 places. Energy nodes is again an array with 2, comma 4 or 2, comma 2, comma 6, 6, comma 2. Oh yeah, 6, comma 2. Sorry for that. And then we type in 16. I think here you can have a maximum size of only 24. Yeah, your grid size is 24, so you can't have anything greater than that, I think. Low, if you're keeping a 0, where is it? Energy node. Yeah, energy nodes, this tells you the position, right? So I'm pretty sure you can't have more than 24 in this. You can keep it 25, I guess, but yeah, let's keep the energy nodes to be 24 only. Right. Yeah. And energy node FNS. What is FNS? I really don't know what it is. But okay, whatever. I'm not sure. I'll have to read through that. We just want a quick benchmark. We don't need to create the best model right now. Energy node mask. Array of true and falses again with size 6, comma 6, comma, correct. Then you have your relic nodes. Relic nodes again, I don't think it can reach above 24. Okay, you have a total of 6 relic nodes. And again, I don't think the position wise it can reach greater than 24, so I'll set up the high there. I think the same should be the case with units, I think. Position can't be greater than 24, so I'll limit it to that to avoid any confusion. Energy can be anything. Energy I'm not worried about right now. And then your relic nodes are set up. Relic node configs, I don't need to worry about that. Yep. After that, finally, you have your relic node mask. Relic node mask is a box with your low high and shape 6 comma, correct. Relic node map weights. I'm not sure what that is all about, but okay. And then you have your map features. Map features has your energy, which is I think 24 comma 24, correct. And again, I think energy can be anywhere to anywhere, so we don't need to worry about that. It can be negative as well, so I think it has taken the care of that. Yeah, dot min dot max, perfect. And then you have your tile type. Tile type, I think the maximum for tile type can be, so you have your, okay, we can quickly check this out. So when we were looking at this, your tile types are, there was something about tile types. Okay, I can't find it. Mm, there was something about tile types, right? Yeah, introduction, I guess it had. Yeah, got it. Background, environment. So in environment, in map. So yeah, you have your empty tiles, 0, and street tiles, 1, 2, 2. So you can only have 3 kind of tiles. Relic position and everything else is different. So yeah, so for where is the tile type? Tile type you can have a maximum of 2. Correct. So that now that is working, and you have your sensor mask, whatever. I think it has done a good job overall. We don't need to worry about too many of the details. Vision power, again an array. I'm not sure what the values can be. Team points 0 comma 0, so that should be straightforward. I think maximum, yeah, we're not sure what the maximum value can be. Team wins, the maximum value, I think we know it can be 5 at max. Not that it should affect our decision any bit, but yeah, let's just have it there. Steps is, yeah, I think time steps maximum you have is 100, right? And max steps. Okay, whatever. I'll just keep them the same for now. So you have your observation space defined for now, and let's see if the dirty benchmark is working now. Let's see. Positional argument followed keyword argument. Oh yeah, what's that? Have I done that? Bro, that's stupid. Uh, what was it? Yeah, I must have deleted that or something. Or I'm not sure. Like, how the fuck did I do that? Yeah, rest everything is fine, right? Okay. Not sure if it will work now or not. Okay, how is it not defined? Name spaces is not defined. Where? Spaces dot gym dot spaces. What the fuck am I doing? Bro, I think you're not restarted. That's your issue. And let's see if it is working now or not. Namespaces is not defined. Oh, is it because I've namespaces is not defined? Yeah, let's copy this file and have it somewhere locally. But then you'll have to worry about whatever. Lux AI wrappers. Let's do it like this. So instead of importing it from here, let's import it from Lux AI wrappers. Let's see if that helps. Clear all, restart. I just want to put this model to training, and then we'll worry about it later if it is working or not, because it will take a while to train. Spaces.it. Oh, okay, am I being stupid? Is that what it is? Oh, and it was not an import problem. From Gym from gym dot import gym dot spaces as spaces. That's what I want. No, I said gym dot spaces, right? Why are you fucking with me? Fucking idiot. Trying to fool me. And sure. What the fuck is wrong with you? Can't you just let me edit spaces? Okay, let's do it manually then. Fuck you, man. VS Code being stupid to us. Yeah, any more gym dot spaces? Oh yeah, fuck that. We don't need gym dot spaces. We need spaces. And any more gym dot spaces out here? Uncultured? No. Good. So now it should be working, right? Let's restart this. Restart. Clear all. We have defined our environment. We have defined our observation space into our environment. Let's see if it helps or not. There is some assertion error now. Assert instant value dot np dot nd array. Where are we facing this? Np dot bool, no? Fuck. Is that it? Is that why we are facing this? Unit mask. Create new array with the D type, but maintain old one to preserve np dot inf. Low is equal to broadcast. What is this error? Is it just that we are using low as false or high? Is that not allowed? Or is it just because we're not using np.bool? But it is not one of the standard ones, right? Can I just get away with this? Hi ChatGPT, I remember you. Yes, long time no see, indeed. It's been a while since I did that Owen project. Owen project was also Owen project was way before. I think the doc query engine has been the latest project. Had you seen that one? The document query engine thing that we are working on. It is not done yet. We have a lot of things to do there. I was also experimenting with. So basically, Docklink says that they are facing issues with their equation detection for now. So I was working with some of the open source models available, and I was really able to find a good one there. So yeah, so we have to also integrate that into Docklink, and we'll have some interesting document query engine ready for us that can work with any kind of a document and convert it into a markdown format that can be easily understood by a language model. And the additional thing will be that we'll be also processing images, as we have many large vision models nowadays, so that we can send the images in the document itself in a formatted way, so that the language model is able to answer in both terms of the from the images as well as the text in your particular PDF. So that's cool. What have you been up to, um, ChatGPT? How's life treating you? And I'm still amazed by how you got that name. So almost looks official. Okay, we are facing an error here. So you need mask. And in low and high, we are facing an issue that, okay, so how to pass in Boolean values in gym environment observation spaces. How do I have the value in observation spaces? Coming from ChatGPT that we should use Cloud. Okay, you're talking about that PDF extraction, right? Yeah, I've not experimented with Cloud Zone yet. I was experimenting with Olama OCR that has recently been released, and it's pretty shit. Like the one that I was working on with Dockling, and we integrated the Rapid OCR into it, that performs way better than Olama OCR, and without using a LLM, that is. So Olama OCR uses a vision language model, and here we are just using your classical models and some 100 MB models that can run locally straightforward without a problem. So that's the best part about it. And regarding Claude, yeah, I think that would be a good idea to experiment with the Claude's PDF extraction, how that is performing. But today we had to focus on this. Today we are focusing on Lux AI Season 3. So here you have to make a robot that can improve the perform like that can basically win a tournament in a game that they have created. And this is a game where you have your units, you place them, you want them to explore, you want them to collect energy, and they should find these relic nodes, and whoever finds the most relic nodes wins. And it's not just about finding the relic nodes, it's also about which position gives points from the relic nodes. So it will give point on a random location and you have to use that, all of those stuffs. That is what we are working on today, and we are not able to train a stable baseline stream model on it. That's what we are stuck at. We have gone through the starter notebook, we understand what we have to do now, but we actually need to improve the performance. Yeah, but okay, I think this was a good starting point for this problem. We got distracted with a lot of other details in the stream, but the major goal is that we want to train a AI model that can do exploration and exploitation at its best, because once a game state is fixed, you want to use that in the future games of the same match to increase your chances of winning. So we'll have to explore some more ideas of how we can improve it. We can read another notebook while we are at it, just to make sure that we understand it. And then our focus would be to actually work with our own ideas. Once we totally understand the approaches people are taking, what all is going on. So let's read one more notebook to actually understand it. So yeah, this is all standard, I think. We're just importing it. You've set up your environment that we have already done. Yep, all good and happy from here. Summary of what this code does: implements an agent class for Lux AI Season 3 competition, reads environment configuration, observation data, then decides action each turn. Uses heuristic logic to explore the map early in the series of matches to discover relic nodes, track non-relic nodes, and attempt to score points from them in later matches. Tracks enemy position using heat map that estimates where enemies might be. Heat map that estimates where enemy might be. How would you do that? From the relic nodes or something? How would you estimate where your enemy might be? They might have a stupid bot that stays at the starting position. You can't. Or maybe just from the exploration you have done, if you can see the enemy state in that, that's what you are estimating. Okay. Consider sapping enemy units when beneficial, especially in later matches. Assign sector of the map to unit for Systematic exploration. Avoid dangerous style like regular tiles with energy drain when possible. Adapt strategy over multiple matches. Early matches, explore and discover. Later matches, leverage discovered information and optimize scoring combat. Yeah, that is exactly what we want to do, but how? Okay, this is all standard move cost. You are calculating sap cost. I'll have to see the sap logic again, what actually it is doing. Oh, there's so much detail in this. Yeah, I think I'll have to read a bit off stream and actually give you the best input I can. But don't worry, we have 3 months for this problem, right? It's only counting days now. We'll figure it out before 3 months easily. So I think this is a good starting point. We understand what we have to do. We have the starter module ready. I hope you are also able to follow up and create this kind of an environment and see if you can figure out what problem I am facing in the stable baselines architecture making. If you can configure that out, solve this bug that we are getting while running the stable baselines 3, then it will be really interesting because we can try to train a RL on it and implement various techniques. I don't see a notebook with RL right now, so that would be the first, and we can work as a team. So if you work on this problem, if you follow along this project and follow these steps to basically set at least this much details and got stable baselines 3, and obviously you will be facing the same bug as I am right now because this is what we are not able to fix. I think somehow boolean expressions are giving us an error or something along those lines, as it is saying that assertion of is instant value a numpy.nd array is failing, which should not, because yeah, it should not, because we are just sending a numpy array. I mean, it should handle itself. We have defined the shape and everything, but maybe the false and true is not able to convert to a numpy array. It is getting converted as list or something. That is something for you to figure out. I'll be figuring out off the stream, and we're looking at all other approaches that are being used to solve this problem so that we can discuss more ideas and explore more experiments to solve this problem in a 3 month time. But yeah, that's how you should start with the Kaggle project in general. I hope the stream helped you. Tomorrow we might be working on some more interesting ideas. We might start working on our project again, that one that has been left for a very long while now, the document query engine. And yeah, see you there. Bye bye. Have a great day or night, as it is in India. So go have your dinner, enjoy your night, whatever you want to do for that. See you tomorrow. Bye bye.